Okay, sir. Thank you.
Thank you, sir.
Thank you,
So
sir.
I already uploaded in the morning. You please check. Okay.
Okay, sir. Let me check.
Hmm.
Sir, announcement. Fine.
Hmm?
Announcement.
So the announcement was regarding like the I cancelled the last class, the Tuesday class. So that's what I'm saying.
What a piece.
So I think we talked about this thing. Okay. We talked about frequency and decomposition, and then time domain and frequency domain we discussed, right? Hello.
Yes, sir.
Yes, we discussed
Yes,
that,
sir.
and all we also discussed. Okay, so let me just start from here so that we can have a review and then start this. Okay. Okay, let me start from here. So if we have a composite signal means like mixture of or combination of multiple signal. And if the composite signal is periodic, periodic means the signals, the shape is repeated. Okay, shape is repeated, like over time. So for example, this is a composite signal with multiple simple signal or multiple sine wave. So we can express all the components of the signal in the time domain. Okay, time domain, time and amplitude, and also in the like frequency domain. So it should be frequency. It's wrong. Frequency. Okay. So frequency domain, amplitude. So here the pink color. So the frequency is less. As you can see, the cycle length is larger. So frequency here. Then the bluish one, so that is the 3, like you see within one cycle of the pink one, the blue one completes 3 cycles, so that's why it is 3f. And the black one, with the one cycle of pink one, it completes the 9th cycle. The black color signal completes the 9 cycles, so it is the 9f. So we express the highest amplitude. So this is the frequency domain, like the representation, frequency domain representation. And the same thing for this one, you see, this is the DC component. That means no change. It is constant over time. That means the frequency is zero. Frequency is zero because there is no change. Okay, no repetition. So frequency is zero, constant voltage. Then the pink one, 8, because in one cycle, 1 second, 8 full cycle, 1 second, 8 full cycle. And the green one, just double, like in 1 second, there are 16 cycles. So frequency is 16. So this is the time domain and it is the frequency domain. Now, if we look at the a composite signal with non-periodic, okay, it is non-periodic. You see, in this signal there is no repetition. It is just a random signal. So there is no repetition. That means non-periodic, or sometimes it is known as the aperiodic. So if we decompose this, so it is a combination of or mixture of continuous frequency, okay, not discrete frequency. Okay, hello.
Yes, sir.
Okay,
Yes, sir.
So so for periodic composite signal, the decomposition is discrete frequency. That means the signal, simple signal with the discrete frequency. You see, the lowest frequency is 1000, highest frequency is 5000, and at different points we have the different components. Okay, so this is for the periodic composite signal. But for non-periodic composite signal, you see the frequency is continuous. You cannot distinguish among the frequency. Okay, so it is for the non-periodic the composite signal. Okay, if you decompose it, okay, if you represent it in frequency domain. Okay, clear?
Yes, sir.
Yes.
Okay.
Yes, sir.
And the difference between highest and lowest frequency is called the bandwidth. It's called the bandwidth of the signal. So for a composite signal, the lowest frequency is the 1000 and highest frequency is the 5000. So the bandwidth of the signal is 4000 hertz. Okay, 4000 hertz. Hello.
Yes,
Yes,
sir.
sir.
Okay. So these are all about the analog signal. All about analog signal. Okay. Hello.
Yes, sir.
Yes,
So
sir.
now let us. So we said that okay, there are two types of data. One is analog and digital data, and we have discussed the examples of analog and digital data, right? Hello.
Yes, sir.
Yes, sir.
And
Yes, sir.
also the signal, that is the signal we use to transmit or exchange the data, the signals are also of two types. One is the analog signal and the digital signal. Both we can use, and we will see what type of signal we use. Now let us now discuss the digital signal. So far we have discussed the analog signal, simple analog signal. Simple analog signal, what is the simple analog signal?
Sine wave.
Only the sine wave. Okay, sine wave. And composite analog signal,
Mixture of sine waves.
hello, I can't hear you.
Compound. Right.
Composite analog signal means mixture of simple signals or simple sine waves. Okay, mixture of simple sine waves. Okay, of
Yes.
different amplitude, of different frequency, or different phases. Okay, so mixture of simple signal is the composite signal, and the analog signal can be periodic and non-periodic, right? When
Yes,
the
sir.
shape repeats, it is called the periodic. When shape does not repeat, it is non-periodic, right?
Yes, sir.
Yes, sir.
Okay. So now let us talk about the digital signal. So digital signal is basically this. Okay, so there is an abrupt change in the amplitude. Okay, so for example, this, and say for example this to this. So that means the change of level is very instantaneous or abrupt. Okay, and there are a number of levels only. Not say for a continuous or analog signal, there are millions of or infinite number of levels of the amplitude, right? Hello.
Yes, sir.
But for
Yes, sir.
digital signal, there are couple of levels. Say for example, if it is plus 5 volt, it is minus 5 volt, or a number of other levels. So the limited number of levels we have in a digital signal, not say infinite or hundreds or thousands of levels in the digital. It is a discrete and a fewer number of levels. Okay.
Yes, sir.
Generally, the number of levels is a power of uh, 2. Okay, to say 2 levels, 4 levels, 8 levels, 16 levels, 32 levels, 256 levels, like this. Okay, so the number of levels is exponent of 2. Okay.
Yes, sir.
Hello. Okay. Now a digital signal, which is the square wave. Okay, so we can represent this, or if we do the Fourier analysis, we can represent a digital signal. It is a composite analog signal. That means if we decompose it, it is a composite analog signal. Okay, it is a composite analog signal. Okay.
Yes, sir.
Okay. Now, and we will see further later on. So, what is the bit rate? Okay, and what is the bit length? So, it is just like how many bit you can transfer per second. So that is the bit rate. Okay, so here you see that in this signal, so in 1 second, how many bits you can transmit? 1 2 3 4 5 6 7 8 8 bit per second, right? So that is the bit rate, 8 bit per second, 8 bps, right?
Yes, sir.
And what is the length of each bit? Definitely 1 by 8, right?
Yes, sir.
Okay, now here in this case, there are two levels, 0 and say plus some voltage, say 0 voltage and say plus 5 voltage. Okay, so this is the 2 voltage, but in the below the figure or the image, you see there are 4 levels. There are 4 levels. So each of them is denoted by say combination of bits, say 0 0 or 0 1 1. So this is the this is the 0 0, and then 0 1 1 0 1 1. So this is how we level. So there are 4 levels. So we need this log number of levels by to the base log 2. So 4 levels. So log 2 4. So log 2 2 2. So 2 log to the base 2. So this is equal to 1. That is 2 bits. If there are 4 levels, they require 2 bits to represent the levels. Okay. If there are 8 levels, we need 3 bits per level. 3 bits per level. Hello.
Yes, sir.
So here you see in this case, in 1 second, we can send 16 bits, because one signal we can send 2 bits, so 16 bit per second. So that's why there are like 16 bps. Okay, 16 bps. Hello.
Sir, level গুলো কিসের উপর ডিপেন্ড করে? কম বেশি হয় লেভেল গুলো?
Hello, I can't hear you. Can you please a little bit loud?
স্যার লেভেল গুলো কিসের উপর ডিপেন্ড করে মানে
So I said, okay, it depends on the designs. If you want to have, say I want to have 8 levels, so that is a part of the design. Then how many bits for each level? So log 2 8, which is 3. Okay, now you can ask me, okay, I want to make it 256 levels, or I want to make it 1024 levels, or I want to make it 32 levels. Okay, so that depends on couple of things. Okay, so how many levels we can use in the system, that depends on some like a lot of things, and we will discuss later on. Okay, we cannot just say use 256 level or 1024 levels or say 128 levels. Okay, so there are certain limitation. We cannot just use number of levels as we wish. Okay. Hello.
জি স্যার।
Yes, sir.
Okay, but this is the formula. So if we use L number of levels, this is the number of bits required. Especially if I become more precise, it will be like this. There will be a cell function. Okay, to the power L. Ceiling function, you know that, right? Cell function.
জি স্যার।
So for example, it is log to the base say 20. So it will be, if it is a ceiling function, so it will be 5. Okay, that is 4 point something, it will be 5. That is next integer. Okay,
Yes, sir.
hello.
Yes, sir.
Yes, sir.
Okay, so this is just an example of that. Okay, so this is what we just mentioned. A digital signal is a composite analog signal with infinite bandwidth. Okay, with infinite bandwidth. Okay, why infinite bandwidth? Okay, so let me explain that. The first thing is, you see the simple signal sine wave for this square wave. This is the digital signal, right? Hello.
Yes, sir.
So this digital signal, a square wave, is represented by infinite. Okay, now why it will be continuous? Because the digital signal is generally, when we transmit data, it becomes non-periodic. Why? Let me tell you why it is non-periodic. Okay, let me just go back to the previous slide. So here you see, is this periodic? This the signal we have just seen here.
No, sir.
Does it repeat the shape? Definitely
No,
not,
sir.
right? So it depends on the data. So since the data is generally or naturally not repetitive in nature, it is random in nature, the data. So definitely the digital signals are not periodic. You see, digital signals are not periodic, these are non-periodic. The digital signals are non-periodic. Okay, and if it is non-periodic, the the if we decompose it, actually we get continuous frequency, the analog signal, continuous frequency analog signals. And the bandwidth requirement for that, it depends on the rate of the digital signal. If the rate is, if rate is high, we need infinite bandwidth. Okay, hello.
Yes, sir.
You got the point. Okay, the first thing is, for a digital signal, it is non-periodic. It is non-periodic. Digital signal, when we need to transmit data, the digital signal becomes non-periodic. So that is the first thing. Second thing is, since it is non-periodic, so we get that means if we decompose it, we get continuous mixture of continuous frequency sine wave. Okay, mixture of continuous frequency sine wave, because the non-periodic, right?
Yes, sir.
Okay, the third thing is, the depending on the data rate or the bit rate we are transmitting, high data rate will require infinite bandwidth. Okay, infinite bandwidth. Okay.
Yes, sir.
Okay, now the question is, from this, like 3 points, non-periodic, then continuous frequency, and then infinite bandwidth. So if we want to send data from one point to another point, we require infinite bandwidth, that is very large bandwidth communication channel or communication link. You got my point, what I am trying to say? That means, say from point A to point B. So if we want to send a signal or send data using digital signal, so we require that very large bandwidth. The communication channel must support huge bandwidth. Hello.
Yes, sir.
Yes, sir.
Okay, then we can successfully transmit the signal. Okay, even, and that is why the communication channel, the practical communication channel, does not support very high or huge bandwidth. Okay, and we'll see later on that the reason. So that is why we don't use digital signal. We don't use digital signal for long distance communication. Long distance communication. Only in a very limited situation. Say for example, uh, inside the motherboard. Okay, from computer motherboard, say from one component to another component, or in the USB drive. Okay, that is very within 1 meter, maximum 1 meter. If the communication is wired and within 1 meter, only that is very limited situation we use the digital signal for transmitting or for exchanging data. Okay,
Yes, sir.
why? Because you see, if the digital signal is periodic, you see the this one is periodic, right? The shape repeats itself, so we get the discrete frequency. But if the frequency, if the signal is periodic, you see the no repetition. Maybe after some point you get this. So there is no repetition of the signal. So we get the continuous frequency signal. Okay, not discrete frequency signal. Okay.
Yes, sir.
So that, and also let me, don't we have this? Okay, let me check it. Yes, I have this. So if we want to pass a digital signal, so it requires very high bandwidth, from 0 to very, very high. From 0 to very, very high. But for a digital signal, for general, the communication link, they support, say, from certain frequency to certain frequency. Okay, the general or normal or natural communication channel, they support, they are called the band pass channel. That is, a particular band of frequency is passed or is supported or is allowed. Okay, so using this kind of signal or this kind of signal is not suitable through the communication channel. Okay,
স্যার নিচেরটা হলো ডিজিটাল।
no, this is for the natural communication channel. And digital signal requires this type of communication channel. Okay,
জি স্যার।
but the natural communication channel is like this. Okay,
Yes, sir.
so
স্যার ন্যাচারাল বলতে কি অ্যানালগ বোঝাচ্ছেন স্যার?
না, ন্যাচারাল বলতে আমি বুঝাচ্ছি, ধরো একটা কপার ওয়্যার, অথবা ধরো একটা ফাইবার অপটিক কেবল। So what type of signal they support? They are band pass channel. That is, from certain frequency to certain frequency they allow. They don't allow from 0 to very high frequency. Okay,
ওকে স্যার।
so for this reason we commonly use periodic analog signal most of the cases, and non-periodic digital signal in data communication. Okay, because you see, if we use this periodic signal, can we transfer data? আমি যদি সবসময় একটা স্কয়ার ওয়েভ পাঠাই, আমি কি ডেটা ট্রান্সফার করতে পারবো?
No, sir.
No.
No, sir.
So we use non-periodic digital signal and periodic analog signal for communicating, for exchanging data. Okay,
Yes, sir.
so communication channel, digital data, analog signal, so analog system with microphone. আমরা যে বিভিন্ন অনুষ্ঠানে মাইক সাউন্ড বক্স ইউজ করি না, so these are, say, from the microphone we speak something, we say something, and then through the microphone it goes to the mic or say sound box. So that is the analog sound system. Okay, or
Yes, sir.
say analog data, digital signal. So when I speak or we say something to a computer and record it, that is the voice recording in computer using mic. So analog data, the digital signal. Then digital data, digital signal, it is PC to printer. Digital data, analog signal, PC to PC, data exchange over the local area network. That is from one PC to another PC or over internet. Okay. So that is the digital data and analog signal. Okay.
Yes, sir.
And that is the most common scenario. Most common scenario. Okay. So you see digital data, digital signal, it is very limited with inside the computer or with computer peripherals or say just USB printer or printer. Okay. So the length of the distance is very limited, at most 1 meter. That's why you will see that most of the USB cable is around 3 feet. That is at most. Okay.
Yes.
Hello.
Yes, sir.
Yes, sir.
Okay. Any question? Any question? No question? Okay. Now, you see in a communication system, say for example, when we speak, that is the analog data. So the analog data is converted into digital format and that is transmitted, you see, that is transmitted using analog signal. Say over telephone network or over computer network, whatever it is, the digital signal is transmitted using analog signal, and on the at the receiver side, it is the digital format is recovered, and the digital format or form is converted into voice again. Okay. Hello.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So you see all the time, the irony is see how many transformation or conversion is taking place. At first it was analog, then we converted into digital, and using analog signal we are transmitting, then we are again converting the digital form into analog. So why don't we just simply say we have the voice, so why don't we using analog signal, we don't do that. So voice using analog signal, then voice. Why don't we do that? Okay.
ট্রান্সমিটার হয়তো বা ডাইরেক্ট অ্যানালগ বুঝে না, ডিজিটালটাকে সে অ্যানালগে ট্রান্সমিট করে।
Okay. So the thing is, sending digital signal using analog signal, sending digital data using analog signal is convenient for the communication system. Sending digital data using analog signal is convenient for communication system. Hello.
Yes, sir.
Why?
Yes.
Can anybody explain why? Can anybody explain or say why this is the case, or what is the reason behind that? That is why I am trying to say that why we do a lot of this conversion. Why voice analog data, then digital data, using analog signal, again it gets the digital data, and then again
That
conversion.
data যাতে secure থাকে।
Why we do this? What is the reason?
To decrease data loss.
What type of data loss?
Maybe if we keep it only analog or only digital, we might lose signal or data on the way.
Okay, you see, okay, what is the digital form of data?
Translator, like it translates the data.
No, definitely say you are converting the voice into digital. No, I'm not talking about it. I'm saying what is the main feature or attribute of digital data? digital data?
It can be stored.
Yeah, okay, one thing then.
Computer can understand.
In the digital format, there are only less number of levels, right?
Yes, sir.
Only a number of levels are there, say 2, 4, 8, 16, 32, or say at best 256, right? That is limited number of levels in digital data, right?
Yes, sir.
But in analog format, how many levels are there in an analog data?
Infinite.
Infinite. So for digital data, to detect the fewer number of levels or less number of levels is easier to detect by the communication system, because the number of levels are discrete and limited, and it is easier or convenient for the data communication system to detect or to differentiate among the levels. If there are infinite number of levels which are in the analog data, it is very difficult to detect the levels and reconstruct the analog signal. You got my point?
Yes, sir.
Yes, sir.
That is the point here. That's why we do this clumsy thing that but এটা ছিল analog, আমি আবার digital করলাম, এটা analog signal দিয়ে পাঠাচ্ছি, again I am converting it into analog signal. Okay, the only reason is in the digital data there are discrete and very limited number of levels in the digital data, which is easier to detect at the receiver end, and so that the design of the communication system is less, you need less complex communication system. Okay,
Sir, is the transmission part easier because it's an analog signal? Like
okay,
if
so
we
generally
use
what we do,
if we
okay,
use okay,
let me
yes, sir.
explain. So what we do, okay, since it, so this analog signal is called the carrier signal. Okay,
Yes, sir.
so we have the data, digital data. Then according to the attribute of the digital data, we change the attribute of the carrier signal. Carrier signal is the analog signal. Okay,
Okay,
carrier
sir.
signal is the just analog signal. So according to the attribute, the levels of the digital data, we change the attribute of the carrier signal, the analog signal. So the change is detected by the receiver end. The change in the carrier signal is detected by the receiver end. Okay, since the change is a limited number of change, so the receiver can easily detect those change. But if we send the analog data, the change would be infinite, right? Because in the analog data, infinite number of levels are there, right?
Yes, sir.
So that is the reason.
Okay.
Sir, question. So when we're converting from analog to digital, we're losing some letters, right?
Definitely. So we will
Sir,
discuss now. We will discuss now.
sir, then won't it be easier if we just transmitted digital data then?
Oh, so okay, can you please repeat again?
Sir, since we are losing some data when we're converting from
Okay.
analog to digital,
Hmm.
won't it be easier if we just transmit it digitally?
Okay, the thing is, if you transmit, okay, the first thing is, the thing is, when you convert analog data into digital, we lose some information. But when we transmit that digital data, we don't lose any information. Okay, you
Okay.
got my point? You got my point? So when,
Yes.
so during this conversion, we lose some information, but when we transmit it, we don't lose any information. Okay, generally.
Okay, sir.
Okay, now we will see like what is the, how we can convert, since it is very common in communication system, how can we convert an analog data into digital form. Okay,
Okay, sir.
hello.
Yes,
Yes,
sir.
sir.
So here you see, so this is our say analog signal, the voice, say for example voice. So you see it is not say it is not the like simple sine wave, right? Because you see the amplitude is here, is this, here it is different. Okay, now we choose or we take some value of amplitude at different interval. Okay, you see the points. So at different interval of time, we detect the amplitude of the analog signal. Hello.
Yes, sir.
Yes, sir.
Yes,
And
sir.
then it becomes the digital data. It becomes the digital data. Hello.
Yes, sir.
Sir.
Now at the receiver end, we do the opposite. So we using a filter, we make it like analog signal again. Using a filter, we make it analog signal. But there will be some loss of data, but this is just like a perfect scenario. Okay. Hello.
Yes, sir.
Yes, sir.
So this is called the analog to digital converter, digital to analog converter, and then we got this, and then using a filter we get this. Okay. So now let me show you like how we can convert an analog data into digital format. Okay. So that part is called the pulse code modulation. So this is the, you can say, very primary primitive version of analog to digital conversion. That means I want to explain you the basic concept, how to convert an analog data into digital form. Okay, pulse code modulation technique. Hello.
Yes, sir.
So
Yes, sir.
used to digitally represent sampled analog signal. That means you take sample of the analog signal. Okay. So there are 3 steps to digitize an analog signal. So sampling, quantization, and encoding. Sampling, quantization, and encoding. Okay. So
Yes.
before we take sample, we have to filter the signal to limit the maximum frequency of the signal as it affects the sampling rate. Okay. I will explain it later on. Filtering should ensure that we don't distort the analog signal. Okay. I will explain it later on. But for the time being, let us explain these 3 steps. Okay. Sampling, quantization, and binary encoding. So here you see, this is the analog signal. So sampling means at different point of time, we take the amplitude, value of the amplitude. Okay, like this. So this. That is at different point of interval, we take the amplitude. Hello.
Okay, sir.
Okay. Then that is called the sampling. Now, what will be the rate of sampling? That is, what will be the interval of taking sample? Okay, so we'll discuss later on. That is how often we take the samples, or what will be the frequency of taking samples, which we discuss in a while. Okay. Now the second step is the quantization. Quantization means, say from the signal you have got this. So this. So 4 samples you have taken, and these are the samples. But we know that in a digital signal, we have a limited number of levels, right?
Yes, sir.
So 4 levels, 2 levels, 8 levels, 16 levels, whatever, right?
Yes, sir.
Yes, sir.
So after taking the sample, we need to approximate the point or the amplitude to the nearest level. Hello.
Yes, sir.
Yes, sir.
We need to assign a level. To each sample. We need to assign a level to each sample, and that is called the quantization. Hello.
Yes, sir.
Now, when we do the quantization or when we assign a level, definitely you see we make mistakes, right? Because there
Yes,
is
sir.
we do some approximation, right?
Yes, sir.
Yes,
So
sir.
we make some mistakes, and that is called quantization error. Quantization error. Hello.
Yes, sir.
Yes.
So now you tell me, say if I have 2 levels and if we have 16 levels, in which case what will be the amount of error? Will it be higher or lower?
Higher in 16
Higher.
levels.
No. You see, if there
Hiring
are
too.
more levels, then the errors will be the minimum,
Yes, sir.
right?
Yes, sir.
So the higher the level, number of levels, the lower the quantization error. Okay, quantization error will be lower, right? Because you will be making less mistake, because you will find a level very close to each other, right? Very close to the sample, right?
Yes, sir.
So the higher the levels, the lower the quantization error. Hello.
Yes, sir.
Yes, sir.
Okay. So the first step is the sampling. The second step is the quantization or quantizing, sampling, quantizing, and coding. So they use noun. So okay, let us say like this, quantizing, and then third one is the encoding. What is encoding? We know that for each level there is a code. Say this is 0000. If there are 16 levels, so each of the level we use, we denote by a number, right? We denote by a code, binary code, right?
Yes, sir.
So for each sample, if there are 16 levels, for each sample there will be 4 bits, right?
Yes,
Yes.
sir.
Now for each second, if there are 100 samples, so there will be 400 bits will be generated per second.
Yes, sir.
Hello.
Yes, sir.
So if the sampling rate is this S, if the number of level is this L, so this is the bit rate. This is the bit rate. Okay.
Yes, sir.
So now the question is, how many level we should use for in this process, and what should be the sampling rate? So these are the parameter. Okay.
Yes,
So
sir.
if you take more sample, bit rate will be high. If you have more levels, definitely bit rate will be high, right? Because this is the multiplication product of sampling rate and the number of bits per level, right?
Yes, sir.
So yeah, actually it will be like this, a sampling rate and this. Okay. Hello.
Yes, sir.
Yes,
Okay.
sir.
So if you increase the number of levels, generated bit rate will be higher. If you increase the sampling rate, definitely the generated bits will be higher, right? It will generate more bits per second, right?
Yes, sir.
Okay.
Yes, sir.
Now you come like, what should be the sampling rate? What should be the sampling rate? Okay. Say, let me show you one thing. Say this is our original analog signal. Say this. Okay. Now, say you take 2 samples. One is here, another is here. So, will you be able to like capture the properties of this signal?
No,
No,
sir.
sir.
Because
No,
only there
sir.
will be 2 point. One point is here, another point is here. So, when you do the filtering, it will give you something like this, right? So you will fail to detect the nature of the voice, right?
Yes, sir.
signal, analog, original analog signal, right?
Yes, sir.
But if you take more samples, say one is here, another 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 is here, then you will be able to capture the signal. Hello?
Yes, sir.
Yes, sir.
But then what should be the maximum limit? From this example I showed you, then we can conclude that, okay, the more the rate, the more the quality, right? আমি যত বেশি স্যাম্পল নেব আমার কোয়ালিটি অফ this conversion will be higher, right?
Yes, sir.
But this is not the case. Okay, so theoretically the Nyquist proved that if the sampling rate is twice of the highest frequency of the analog source signal or analog signal, twice of the bandwidth of the highest frequency of the analog signal. So for example, this analog signal, the minimum frequency, say for example 100, highest frequency is say 4000, for example. So if we sample in 8000 hertz, that is good enough to reconstruct the signal at the receiver end. You got my point?
Yes, sir.
স্যার একটু আরেকবার বলবেন
Okay.
একটু
Say the original signal we are converting into digital. The highest frequency of the original signal is 4000 hertz. That means highest. We know that in a composite signal there is a minimum frequency and highest frequency, maximum frequency.
Yes, sir.
Okay. So if you sample at the rate of twice of the highest frequency, so highest frequency is 4000 hertz. So if we sample at 8000 hertz, that is good enough. We don't need to sample more than that. Okay.
Okay, sir.
If the sampling rate is twice of the highest frequency, that is good enough to reconstruct the signal. Okay.
Yes, sir.
Okay. So now you have got the boundary for the sampling rate. Okay. Now let us go back to the two two state that sentence we have seen earlier. These two lines, that before we sample, we have to filter the signal to limit the maximum frequency of the signal as it affects the sampling rate. Okay, what is that? Say I have an analog signal. Composite analog signal we are going to convert. So most of the component of the analog signal is within say 100 to 4000. Very less, very minor portion, okay, very small, insignificant portion is within this region. So up to say 10,000, for example. But this is very insignificant. So we should exclude that part and we should include the important part of the signal. Okay. So if we filter it up to like 4000, then we can sample the signal at 8000 hertz. Okay. So if we take this, or if we consider this, we need to sample at 20,000 hertz, right? Hello.
Yes, sir.
You got the point?
Yes, sir.
Since this is very insignificant, we can avoid this. So we can sample at lower frequency or lower rate or lower interval. Okay. Hello.
Yes, sir. Understood.
Yes, sir.
Okay.
So by chance if signal started from 2000 hertz, done.
Bolo?
If the signal started from 2000 hertz instead of 100 hertz, তাহলে কি আমরা 8000?
Yes, it depends on the highest frequency, not on the lowest frequency. Okay, whether it is 100, 2000 or 3000, it does not matter. You need to check the highest frequency. Okay.
Okay, sir.
Okay. Okay. So filtering should ensure that we don't distort the signal. That means what it says, that if in this part there are some important component is there within this part, then we should not ignore that part. Okay, you should ignore it, or you should remove it only if this part is very, very insignificant. Okay, hello.
Yes, sir.
Okay, so any question from this, that PCM?
স্যার একটা জিনিস একটু মানে ফিল করতে পারতেছি না,
বলো, তোমার কথা বুঝতে পারছি না।
মানে স্যার একটা জিনিস একটু ফিল করতে পারতেছি না, যে মানে পিরিয়ডিক সিগন্যালের ক্ষেত্রে স্যার 4000 হার্টজে ম্যাক্সিমাম হবে, অথচ 10000 হার্টজে জিনিসটা ম্যাক্সিমাম হবে না, বা অনেক কম হবে, যেটা আমরা বাদ দিতে পারবো। কিন্তু একটা পিরিয়ডিক সিগন্যালের ক্ষেত্রে এই জিনিসটা কি সম্ভব? মানে 4000 এই সব আছে, বাকি 10000 এ খুবই কম ডাটা।
Okay, let me explain. Say for example, this is a composite signal. Okay, so this is the signal from my voice, for example. Okay, hello.
Okay, sir.
So here we have only 3 components: this one, and this one, right?
Yes, sir. Yes, sir.
Okay, now you see this component, the amplitude is very, very small.
Yes, sir.
So now if we consider all 3, so we need to say f equal to 100, say 1000. So if we take all these 3, that means we need to sample 18,000 per second. Sampling rate should be 18,000. Hello.
Yes, sir.
And but we see from this we see that this component is very, very small, magnitude is very, very small. So we should exclude this part from my voice signal, and in that case we can sample at only 6000 hertz.
Yes, sir.
You got my point? You got that point now?
Yes, sir, I got it. Thank you.
That means this frequency is very, very insignificant, amplitude is very, very small, so we can ignore those amplitude or those component. Okay, we take only the major component, the major contribution of the signal, composite signal. Okay,
ওকে স্যার, মানে অ্যাম্পলিটিউড বেশি আর কি, ওই জন্য মানে অ্যাম্পলিটিউড বেশি যেটা সেটা নিতেছে আর কি।
yes, because this smaller amplitude has very minor contribution in the overall composite signal. Okay,
Yes,
Sir, it's like if we talk about the voice, it's like the noise behind our voice.
yes,
Those-
exactly.
Okay, sir.
So this is basically the gray color is the original analog signal. So you see, so this is the red color is the after quantization. Okay, so definitely from the analog signal we do the digitization or digital data, digital form, and definitely you need to remember that is not the true representation of the analog signal. It is not possible, right? So it is just an approximation of the analog signal, or just you said that's close to the analog signal. It is not the exact representation of the analog signal. Okay,
sir.
But if you increase the number of levels and if you take enough samples, and that is good enough to represent or reconstruct the analog signal at the receiver end. Hello.
Yes, sir.
Okay, now let me tell you one very practical example. So when we speak over phone, so we can understand each other, right? The voice, from the voice we can recognize what the other end is saying, right?
Yes.
But when we exchange a telephone number, or when we exchange a spelling of certain word, we cannot differentiate what is the difference between B and D, what is we need to repeat couple of times. Say A for Apple, B Bangladesh, D Dhaka, N for Nepal, right?
Yes, sir.
Yes, sir.
You got that, but that means the voice is transmitted over telephone line or telephone channel. Those are not the exact representation of the voice. It is just an approximation, and that is why when we spell a word, we need to say, when we spell a letter, say A for say apple, A, the other end does not understand what is what A or B, something, say B or D, right? B or T, something like that. Especially B and D, they becomes confused, right?
Yes, sir.
That because though it is understandable, but if we want to know the fine details, you can sometimes we fail to detect the voice. We fail to detect the voice. We need to so because that is not the high quality representation of the original voice. Okay.
Okay, sir.
So now you see there is a very simple problem. Say a digitized voice channel is made by digitizing a 4K kilohertz bandwidth. Okay, so bandwidth of the voice signal, is 4000 hertz. Okay, original bandwidth. Okay, that means highest frequency is the 4000. Okay, we need to sample the signal at twice of the highest frequency. We know that, right? Okay. Then we assume that each sample requires 8 bits. 8-bit means 2 to the power 8. That means 256 levels are used. From here we can understand. Each sample requires 8 bits, means there were 256 levels. What is the required bit rate? Hello? So the
Yes, sir.
sampling rate is 8,000, right? Hello?
Yes, sir.
Okay, now sampling rate is 8,000. That means per second there will be 8,000 samples. Hello?
Yes,
Now,
sir.
Yes,
Yes, sir.
now for each sample there will be 8 bit.
Yes,
Yes,
sir.
sir.
So how many bits per second? 64,000
4,000.
bits per second. Okay, or 64 kbps. Clear?
Yes, sir.
Yes, sir.
Okay. So we get digital data from analog data using PCM, passed code modulation, and digital data, you see. So from the PCM, so we get from analog data, we get the digital data, right? Hello?
Yes, sir.
yes, sir.
And so this digital data, we can transmit using digital signal. That means that we have seen the digital signal, and also using analog signal. Okay.
Analog signals.
Okay.
Okay, sir.
And more specifically, non-periodic digital signal and periodic analog signal. Okay.
Okay, sir.
Periodic analog signal. So let us at first see this. Okay, the digital signal. Then we will see how to transfer digital data using analog signal. Okay.
Yes, sir.
Okay. So to transmit digital data, so we don't use just like, say for example, for 0 we use this, for for 1 we have used 5 volt, for 0 we say 0 volt. It is not That's simple, okay? Like very simple, says for 1 5 volt, for 0 0 volt. It is not like that, okay? So to send digital data using digital signal, we use some codes, okay, which are known as the line code, okay, which are known as line codes, okay? So if say to transmit this digital data, okay, what digital signal we should use? Definitely these are, you see there's some square wave, but it is not like, say for 1 it is +5, for 0 it is 0 volt. It is not like that, okay? Something else. So there are couple of schemes for the line codes, okay? So one is called non-return to zero code, NRZ non-return to invert, NRZ invert, NRZ I, Manchester coding, or bipolar encoding. Okay, so these are different schemes for transmitting or for exchanging the digital data. Okay, hello.
Yes, sir.
Okay, so now you see the first one. So we want to send 1, so the level is high. Now when we want to send 0, the level is 0, okay? For 1 it is 1, for 0 0, for 1 1. So very simple, okay? NRZL, sometimes it is known as NRZL, okay?
Yes, sir.
The second one, NRZ invert. So when it needs to transmit 1, it changes the level. So it was 0, it becomes 1. And when you need to transmit 0, it does not change the level. It does not change the level. When you get 1 again, it changes the level to 1 to 0. Hello?
Yes, sir.
That means NRZ, I means when you get 1, you change the level. At the middle of the signal, you change the level. Hello?
Yes, sir.
Yes, sir.
So this encoding, or this line code is used in USB communication. এই যে তোমরা USB ড্রাইভে যে এই যে ফাইল ট্রান্সফার করো, this encoding is used, okay? NRZI. So when it needs to transmit 1, it changes the polarity of the signal, okay? If it is 0, it goes to 1. If it is 1, it goes to 0 at the middle of the signal, okay?
Yeah, okay, sir.
Yes.
Hello? Okay. Then the third one is the Manchester encoding. It uses a clock pulse. Okay, so you see it is similar pulse all the time. So when you need to send 1, you just invert the clock pulse. You see, just opposite of the clock pulse. When you need to send 0, you send the clock pulse. Very simple. So if it is 1, you send the inverse of the clock pulse. If it is 0, you send the clock pulse, okay? Hello?
Yes.
Yes.
The bipolar encoding, when you need to send 0, it is the 0 volt, and when you need to send 1, sometime it is the positive, next time it is negative, next time it is positive, and again it is negative, okay? That means that when you need to send 1, you change the polarity of the last time, okay? But for 0, it is you send the 0 voltage, okay?
Sir, sometimes positive or sometimes negative হলো কিভাবে স্যার এখানে?
এই যে দেখো, আগে ছিল 1 পাঠানোর জন্য you send +5, next time it will be -5, next time +5, next time -5, +5, -5.
Okay, sir.
But for 0, always it is 0 volt, okay?
Okay, sir.
Okay, there is a reason for that. If you do this, the average voltage in the communication channel will remain 0, right?
Yes, sir.
Yes.
Because the probability of zeros and ones in the data is half or 50%. So the average voltage in the channel or in the wire it will be 0. Okay. Hello.
Yes, sir.
Okay.
স্যার ম্যানচেস্টারটা একটু আরেকবার বলবেন, ওটা বুঝি নাই।
Okay. So Manchester. So there is a clock pulse. They both the sender and receiver, they maintain a clock pulse. Okay. So
Okay.
so when you need to send one, so you invert the clock pulse. So inversion means what? XOR.
Opposite.
You see, তুমি দেখো আমি যদি 0 এর সাথে 1 করি, XOR করি, it will be 1. আবার 1 এর সাথে 1 দিয়ে XOR করলে it will be 0.
0, yes, sir.
So that means the inversion. If you XOR by 1, XOR with 1, you get the opposite signal, right?
Yes, sir.
So you see, so if you XOR the data signal with the clock pulse, you get the data signal. You see, 1 with the clock
yes,
pulse,
sir.
you get the opposite of the clock pulse, right?
Yes, sir.
So that is the Manchester encoding.
Okay.
বাইপোলার কি কোনো প্যাটার্ন ফলো করে? মানে ফার্স্টে যখন 1 ছিল তখন +5 ভোল্ট, তারপরে 0 তে সে আবার 0 হয়ে গেছে, তারপরে আবার যখন 1 আসলো তখন সে -5 কেন হলো? মানে এটা কি কোনো
because last time it was +5, that's why it is -5.
আচ্ছা স্যার, তারপরে যখন আবার 1 হয়েছে তখন সে পজিটিভ, তারপরে
+5 মানে আগের বার পজিটিভ থাকলে পরের বার নেগেটিভ।
না স্যার, এই যে মানে -5 থেকে যখন মানে -5 থেকে তো আবার পজিটিভ হলো না 0 এর জন্য?
হ্যাঁ হ্যাঁ
নিউট্রাল হলো।
হ্যাঁ।
আচ্ছা,
না
তারপরে
না 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 0 এর জন্য নিউট্রাল না। ফর 0 অলওয়েজ ইট ইজ 0। 0 এর জন্য কিছু হচ্ছে না কিন্তু। ফর 1 sometimes it becomes positive, sometimes it becomes negative. For 1.
আচ্ছা স্যার, মানে আগেরটার সাথে কম্পেয়ার করে। আচ্ছা স্যার, বুঝতে পারছি।
আগের 1 এ কি ছিল ওটার সাথে কম্পেয়ার করে।
আচ্ছা স্যার, বুঝতে পারছি।
ওকে
ওকে স্যার।
So this is all about the transmitting digital data using digital signal, and these are known as the line codes, couple of very common line codes. Okay.
ওকে স্যার।
So now the question is, like, why don't we use this digital signal for in communication system? Okay, and আমরা কেন digital signalটা use করি না? So I already explained earlier, but let me explain it again. So baseband transmission means sending digital signal over a channel without changing the digital signal to a analog signal. Okay, what does it mean? So we have the digital data. So definitely we can send digital data using analog signal. But if we send digital data using digital signal, okay, digital signal at a constant rate, say 100 bit per second, 500 bit per second, or 1000 bit per second, whatever the rate, if we send digital data with digital signal, ওই যে কিছুক্ষণ আগে আমরা যেটা দেখলাম, so this is called the baseband transmission. Baseband and transmission, and definitely this is non-periodic, right?
Yes.
এই যে দেখো এখানে কি কোনো পিরিয়ড আছে এই ডেটা এই ডিজিটাল সিগন্যালের মধ্যে? Because it differs, the shape depends on the input data, right? What you want to transmit, right?
Yes, sir.
Yes, sir.
So it is definitely non-periodic. Okay. Now for the non-periodic digital signal, okay, if the bandwidth is very, very high, wide bandwidth channel, the output signal is like this, because the input signal bandwidth is, you see, 0 to infinity, very high. So if you have a very high bandwidth channel or medium, communication medium, so you can get the signal almost very much close to it. Okay, but most of the communication channel, already it is there, what we have written couple of minutes ago, most of the communication channel are like this. That means it does not support from 0. It supports from certain frequency to certain frequency, which is called band pass channel. Okay, so if you want to transmit a signal like this using a band pass channel, you cannot do that. Okay, it will miss, or it will lose some of the part of the signal, some part of the signal. Okay, so that's why you see, the baseband transmission of a digital signal that preserves the shape of the digital signal is possible only if we have a low pass channel with an infinite or a very wide bandwidth. কথাটা বুঝছো? That is, if we want to transmit digital signal, so that requires very high bandwidth channel, okay? And in baseband transmission, the required bandwidth is proportional to the bit rate. If we increase the bit rate, the bandwidth requirement will be high. Okay, if we need to send bits faster, we need more bandwidth. Hello?
Yes, sir.
Yes, sir.
Okay. So that's why we don't use digital signal, okay? Because of this phenomena, because we need to send the digital signal, we need huge bandwidth. Okay, so if the available channel, which is a band pass channel, and available naturally channel gulo hoy band pass channel, we cannot send the digital signal directly to the channel. Okay, we cannot send the digital signal directly to the channel. So what do? We need to convert the digital signal to analog signal before transmission. আমরা যে ডিজিটাল সিগন্যালটা আছে, দেখো এটা একটা কমপ্লেক্স কথা, চিন্তা করো। So we have voice, we convert the voice into digital form using PCM technique, and again we are saying this for digital form we use an analog signal to transmit the digital form. We use digital signal, and then from the analog signal, received analog signal at the receiver end, we extract the digital format. We extract the digital form, and again it is converted to voice. Hello? Why we cannot use the digital form of data using digital signal?
We require high bandwidth.
We require huge bandwidth. We require high bandwidth. Okay, low pass and high bandwidth. That's why we cannot directly send the digital signal. We need to convert the digital form into analog format. Okay, and this conversion, digital form to this is called modulation. Actually, it is not conversion. It is some sort of you change the attribute of the digital signal according to the digital form of digital data. Okay, that is not conversion. That is the modulation. Okay, modulation. You modulate the analog signal or carrier signal according to the digital data, and that is called the modulation, and this is known as the demodulation. Okay. Hello?
Yes, sir.
ওকে স্যার।
Yes, sir.
এবং এই দুটো মডুলেশন এন্ড ডিমodulation. Modulation and demodulation. So these two names, from these two names we get the device modem. Modem does this thing like modulation and demodulation. Okay, modem. Hello? আমাদের প্রত্যেকের বাসায় যাদের ইন্টারনেট কানেকশন আছে প্রত্যেকেরই একটা দেখবা মোডেম আছে, whether it is fiber optic connection or even coaxial cable connection, whatever the connection is, there is a modem. Okay, for this task, that modulation and demodulation. Okay,
ওকে স্যার।
Yes, sir.
any question up to this?
No, sir.
Okay. এই যে দেখো আমি যেটা বললাম স্যার, দিস ইজ ইউর ইনপুট সিগন্যাল। ওকে, দিস ইজ ইউর ইনপুট সিগন্যাল, and this is your analog signal, input analog signal. So according to the amplitude of the input signal, you change the frequency of the the carrier signal. Okay, frequency of the analog signal. Okay, you change the amplitude. So for 1 high amplitude, for 0 low amplitude. So using a band pass channel, you can pass it at the receiver end. From the change in at amplitude, you can detect what was sent to the receiver. Hello.
Yes, sir.
So this is the modulation. This is the demodulation. Okay. So you get the signal here. Okay. Since in the
Yes, sir.
digital signal there are few number of levels, at the receiver end it can detect the change in amplitude. Okay.
Yes, sir.
Any question? So these are very fundamental concept of communication, and you must understand. You must understand. Okay.
Okay, sir.
So hopefully in the next class we will be done with this slide.
স্যার
And
এই টুইসডে কি ল্যাব হবে স্যার?
হবে তোমাদের lab instructor has been assigned. So hopefully you will have a lab, at least the introductory lab, first lab on Tuesday. Okay.
ওকে স্যার।
Your lab instructor is Nahin. So let us stop here and let me take the attendance. So let me take the attendance. Today is why I see this. Okay. So
স্যার আমাদের ভার্সিটি খোলার ব্যাপারে অথরিটি কিছু বলছে আপনাদের?
okay, so today we are supposed to take classes from the classroom or even from our office room, but somehow it has been delayed. So definitely university will let you know. Okay.
স্যার আপনার টিচার ফ্যাকাল্টিদেরকে স্যার এভাবে মানে ক্লাস থেকে ক্লাস নেওয়ার মানে রিজনটা স্যার আমি বুঝতে পারছি না।
এটা হচ্ছে হয়তো মানে এটা হচ্ছে ফার্স্ট স্টেপ, সেকেন্ড স্টেপে হয়তো করবে যে তোমাদের 50% কে বলবে রোববারে আসতে আর বাকি 50% কে বলবে মঙ্গলবার আসতে।
এটা কি স্যার এই সেমিস্টারেই পসিবল?
হ্যাঁ, তাই তো করার ইচ্ছা।
আচ্ছা স্যার।
এভাবে করলে স্যার পুরো সিলেবাস কভার করা সম্ভব?
না না না, কেন 50% ক্লাসে থাকবে, 50% তোমরা বাসা থেকে জয়েন করবে।
ও আচ্ছা
স্যার ওইটা একটু আনফেয়ার হয়ে যায় না?
কেন, তুমি তো আবার নেক্সট ডে তে তুমি ক্লাসে যাচ্ছ, ওরা বাসায় থাকবে, তাই না?
অ্যাকচুয়ালি আমরা সবাই সেম ক্লাসটাই করতেছি, আমরা একদিন অনলাইনে করব একদিন অফলাইনে করব।
এক্স্যাক্টলি।
আর এক্সামের ক্ষেত্রে স্যার?
এক্সামের ক্ষেত্রে সবাইকে আসতে হবে, আসলে তোমরা অনেক বেনিফিট পাইছো, বুঝছো?
স্যার এক্সাম বলতে কি মানে শুধু মিড আর ফাইনাল, নাকি কুইজও ভার্সিটি যে দিতে হবে? কোনো ডিসিশন কি হয়েছে?
না না, এগুলো আসলে ডিসিশন হয় না।
আচ্ছা আচ্ছা।
কিন্তু আশা করি যে এবার এক্সাম গুলো এট লিস্ট ফাইনাল এক্সামটা তোমার ইয়েতে হবে আর কি, ফিজিক্যালি হবে। হ্যাঁ, ওকে। সামিন আহমেদ।
স্যার।
উলফাত আহমেদ অ্যাবসেন্ট। দেন শাহিন আহসান
প্রেজেন্ট স্যার।
শাকিফুল আলম
প্রেজেন্ট স্যার।
আব্দুল্লাহ বিন আলী
প্রেজেন্ট স্যার।
দেন সোয়াদ আহমেদ অমিত
প্রেজেন্ট স্যার।
মুরসালিন কবির অ্যাবসেন্ট। দেন হাফিজ আল আসাদ
প্রেজেন্ট স্যার।
আতিক মাহমুদ অয়ন এম বারি।
আতিক মাহমুদের নেট চলে গিয়েছে স্যার।
আচ্ছা, এম বারি অ্যাবসেন্ট। দেন আসিফ দেওয়ান
প্রেজেন্ট স্যার।
তাসনুবা সালমিন অ্যাবসেন্ট। আনান ঘোষ
স্যার চ্যাটে লিখছে আনন্দ ঘোষ।
চ্যাটে লিখলে হবে। আচ্ছা, আরেকজনকে Atik Mahmud Oyon. Okay, to dilam. Okay. Then Muzammil Haq.
Present, sir.
Mehdi Hassan. Mehdi Hassan.
Yes, sir.
Then Walid Hassan.
Yes, sir.
Saqib Hassan.
Present, sir.
Tanvirul Hassan.
Present, sir.
Tanvir Ibn Hussain.
Yes, sir.
Ismat Jahan.
Present, sir.
Then Nahid Hussain.
Yes, sir.
Ausaf
Present,
Mahmoud.
sir.
Then Iftekhar Masood.
Present, sir.
Then Ifaz Tahmid.
Present, sir.
Kaji Mosaddiqur.
Present, sir.
Shahjalal Mondol.
প্রেজেন্ট স্যার।
Then Tushar Sarkar.
Present, sir.
Abdullah Al Said.
প্রেজেন্ট স্যার।
Mohsina Binte Sams.
Present, sir.
Sadman Shobnil. Mosharraf Hussain.
Present, sir.
Then Tawfiqul Islam. Tawfiqul Islam Talukdar absent. Then Farzana Yasmin.
Yes, sir.
Mushfiq Uddin.
Present, sir.
Then Rizwanul Wahid.
Present, sir.
Priti Chaudhuri.
Present, sir.
Sabbir Ahmed Shajal.
Present, sir.
Okay. Then Rashik Ishraq Nahian. Rashik Ishraq Nahian absent. Okay. So I think we are done for today. So let us.
আচ্ছা স্যার, আপনাকে একটা কোশ্চেন আস্ক করতে পারি?
হুম।
আপনার গুগল মিটটাতে জয়েন করতে হলে আমাদের ম্যানুয়ালি পারমিশন